Hello, today we will discuss about ionic equilibria. Actually, we initially start from the definition of strong and weak electrolyte. Now, we first define what is strong electrolyte. Strong electrolyte the electrolyte which completely dissociate in aqueous solution is called strong electrolyte. Example, NaCl. Now, if we take 100 molecules of NaCl in aqueous solution, it will completely dissociate and form Na plus and Cl minus. Actually, the number of Na plus is 100 and number of Cl minus is also 100. It is a hypothetical number 100. If you take 1000 molecules of NaCl, you will get 1000 Na plus ions and 1000 Cl minus ions. Now, there are some electrolytes which doesn't completely ionize in aqueous solution. They are called weak electrolyte. Weak electrolytes are those which does not completely ionize in aqueous solution. As for example, acetic acid. Acetic acid in aqueous solution dissociates as acetate ion and H plus ion. If we take 100 molecules of acetic acid, hypothetically the number of acetate ions will be 2 and H plus is also 2. That means 98 molecules of acetic acid remain undissociated. In this case, we define a new term called degree of dissociation. It is represented as alpha. Now, what is alpha or degree of dissociation? The fraction of weak electrolyte which get ionized in aqueous solution is called degree of dissociation. Actually, if we consider the previous case, the degree of dissociation of acetic acid is 2 divided by 100, that is 0.02. This is degree of dissociation of acetic acid. And if we want to calculate the degree of dissociation and concentration of electrolyte, we should discuss about Swell's dilution law. What is Swell dilution law? Swell dilution law is that degree of dissociation of weak electrolyte is inversely proportional to the square root of molar concentration of the weak electrolyte. Now let us deduce the Swell dilution law. Let us consider a weak electrolyte AB. Now AB dissociates as A plus and B minus. If the number of molecules of AB is 1 and degree of dissociation of AB is alpha, then the number of A plus ion is alpha and number of B minus ion is also alpha. And what will be the remaining part of AB? This is 1 minus alpha. If we take C molar concentration of AB, then the concentration of A plus is C alpha, B minus is also C alpha, and AB is C into 1 minus alpha. Now, dissociation constant of AB, K, is equal to molar concentration of A plus multiplied by molar concentration of B minus divided by molar concentration of AB. Now, molar concentration of A plus is C alpha. Molar concentration of B minus is also C alpha. And molar concentration of AB is C into 1 minus alpha. Now, C is cancelled. So, the equation becomes C alpha square divided by 1 minus alpha. Now, 1 is much more greater than alpha because the electrolyte is weak. That is, 1 is much more greater than alpha. So, we can write K equal to C alpha square. Therefore, we can write alpha equal to root over Ka by C. This is called Swell Dilution Law. This is an unique law. Actually, this indicates if the concentration of the weak electrolyte is low, its dissociation is greater. That means 10 to the power minus 3 molar acetic acid dissociates more than 10 to the power minus 2 molar acetic acid. That's all for strong electrolyte and weak electrolyte. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.